Hello everyone, you're welcome once again to another math class. Today in a lesson we'll be looking at addition and subtraction of whole numbers and addition and subtraction of decimal numbers. But for a start, we are going to look at the addition and subtraction of whole numbers. So here we have two examples on the board and we are going to look at them together. So the first example here, we have the numbers 3,462 added to 5,327. Okay, now let me quickly bring this out, that the examples we have here right now are those that do not involve regrouping. I know by now you know what regrouping is about, when you don't have to have any extra or spillover that cannot stay in a particular part and you move it to the next section. So this is without regrouping. Okay, then after this we look at with regrouping and then we look at subtraction before moving on to decimal numbers. Okay, so the first one here we have 2 plus 7. The bigger number is 7, right? You can keep this in your head and add on the remaining 2. So 7, then you count 2 more steps, 8, 9. So 7 plus 2 or 2 plus 7 is 9. The next one is 6 plus 2, 6. Count on 2 more steps, 7, 8. 2 plus 6, 8. The next one is 4 plus 3. So 4, count 3 more steps, 5, 6, 7. You have your 7, and then 3 plus 5, you have your 8. 5, count on 3 steps, 6, 7, 8. Okay, this is as straightforward as it can be. I'm just starting from here. I know this is not something that we should really be looking at this stage, but we need to start from here and pick up to other levels where we ought to be. So the second example here says 7 plus 2. So you have 7, add on 2 more steps, 8, 9. So you have 9. 8 plus 0, you have 8. You're adding no step, so 8 plus 0 is 8. 5 plus 2, 5. Add 2 more steps, 6, 7. So 5 plus 2 is 7. And lastly, 6 plus 1, 6. Add on 1 step, 7. So 6 plus 1, 7. So you have 6,587 plus 1,202. It gives us 7,789. So these two that we just looked at now, they are examples of addition without regrouping. They are straightforward addition without regrouping. So we're going to look at 2 other examples that involve regrouping. So the next example we're going to look at now is addition of whole numbers with regrouping. The one that involves regrouping. Okay, so let's begin. Remember, whenever you're doing your addition or subtraction, you always start from the extreme right end, that is the unit side, and that's the side that has the least value. So we start 2 plus 3. You can always keep the bigger number or digit in your head and add on the other steps. So 3 in our head, we add 2, 3, 4, 5. So 2 plus 3 is 5. Now 6 plus 5, have 6 in your head, you add 5 more steps. You can use your finger to complete that. So 6, 7, 8, 9, 10, 11. So 6 plus 5 gives us 11. We know we cannot put 2 digits under the same column. So what do? We put down the unit digit and we bring the other one here. We regroup. That is the regrouping we are talking about. We are regrouping, rearranging. Okay, so we put down the unit value down here and we move the other to the other side. Now, because it is supposed to be 11 tenths, and we cannot house 11 tens under tens column, we will take 1 tens. This first one here is 1 10, and then the remaining 10 tens, remember 11 is 10 and 1, isn't it? Now since this is under tens, that means this 1 and 1 that would have been written here is 11 tens. Let me write it here for you to see. Okay, let's write it there. 11 tens. That's what this 11 is supposed to be. Okay, but we know we cannot write 11 under this place. So what do? We split it up. 11 tens is actually 10 tens and what? 1 10. Right? 10 tens and 1 10. We are splitting it up. So what happens? We can keep the 1 10 because 1 as a digit can stay up to 9. It can stay because those are the single digits. So we retain the 1 10, which is this. And the 10 tens means what? 10 in 10 places. 10 times 10. That gives us what? 100. So the 10 tens will now come to the place of 100 to be 100. Because 10 in 10 places is actually 100. So we converted that 10 tens to 100 and we bring it to the column of 100. So we're going to add 1 plus 4 is 5. 5 plus 6. So 6 in my head. I count on 5 more places. 7, 8, 9, 10, 11. 6 plus 5 is 11. So again, we encounter the same problem. We cannot write 1100 under 100 because it's not possible to have 2 digits there. So again, we check 1100. Let me write it. Let me clean this off. 1100 is actually 10 hundredths plus 100, right? 11 is actually 10 plus 1, isn't it? So this 1100 that would have been under 100, but it's not possible, we split it up to 10 hundredths and 100. And again, the only one we can keep is the 100 that is 1 digit. So we keep our 100. But what happens to the 10 hundredths? Now 10 hundred means 10 in 100 places, that is 10 times 100. And 10 times 100 is equal to what? 1000. So that 10 hundredths becomes 1, just 1000. We move it here to the column of 1000 as 1000. Okay, I hope it's getting clear. So we move that as 1000 to the column of 1000. So we add it to what we have under the column of 1000. 1 plus 3 is 4. 4 plus 2 is 6. So our answer is 6115. This is an example of addition with regrouping. Okay, let's take one more example in this category. So another example of addition with regrouping is what we have right here on the board. So this is our second example. Now let's start from the unit end as usual. Okay, we always start our addition from the extreme right end. So here we have 6 plus 8. So 8 is the bigger number. We can keep that in our head and we add on 6 more places. Okay, starting from the next number after 8. So 8, 9, 10, 11, 12, 13, 14. You can count your fingers anyhow it suits you. So 6 plus 8 is 14. Okay, let me write my 14. You tell me if I'm right or wrong, okay? So 6 plus 8 is 14. So that's my 14. Does it look right? I doubt so. I don't believe it looks right. I don't think it looks right. Okay, remember we said we can't have 2 digits under 1 column. So what are we going to do? We keep the units and we move the tens. Okay, because 14 is under this unit that you see right now represents 14 units. This means 14 units. But we can't have 14 units here, so what do? This 14 units is the same as 10 units plus 4 units, right? 14 units is the same as 10 units plus 4 units. So we can only keep the 4 units because it's one digit, it's a single digit. So here we write the 4. Then what happens with the 10 units? Remember, 10 units gives you, is equal to 110, isn't it? 10 units gives you 110. So that 110, which is the 10 units, we move it to the column of tens. Okay, so you have 1 plus 3, 4, 4 plus 2, 6. Right? So next we have 9 plus 4, so we have 9 in our head. We can count 1 to 4 more places, 10, 11, 12, 13. So again, we have 2-digit answer, but we know we can't do that. So 13 is the same thing as what we did here. We do it again. 13 is equal to 13. If you look at it, this is under hundreds, right? 13 hundredths. That's what 13 hundredths. Okay, let's get this out so that we can have space. Now, what does 1300 mean? It means 10 hundredths plus 3 hundredths, because 13 is 10 plus 3, isn't it? Good. So 1300 means 1000 plus 300. Now, if we look again, 10 is 2 digits, 3 is 1 digit. So we can only pick the one that is 1 digit, which is the 300. So instead of writing the 2, we pick the 300s and write it there. Remember, the 3 is under 100. Now, what happens with the remaining 10 hundreds? 10 hundreds simply means 10 times 100. 10 times 100 gives us 1000, and that number is 1000. So 10 hundredths is 1000. So that means the 10 hundredths that we have is changed to 1000. So you see it comes to the family of 1000. 10 hundredths is 1000, so it becomes 1 and comes to this column. So here we add it, 1 plus 1, 2 plus 5, we have 7. So our final answer is 7,364. So let me quickly go over this addition with regrouping again. Okay, in addition with regrouping, anytime you add any two numbers and the answer you get is 2 digits, you retain the one on the right side, which is the unit position normally. So retain the unit in that column and take the other to the next column as 1. Take it as 1. Or if it is a number that is not in the tens, maybe it's in the it's up to 20s or 30s, whatever it is, just retain the digits in the unit position, and the other one in the tens position, you move it to the next column. That's just the basic rule. Now, I'm just explaining all this to you because somebody will say, but is it not tens? Why are you moving tens to 100? So I'm just trying to show all this, that wherever the digits appear, that's the value they take. 9 here under 100 is 900. 4 here under 100 is 400. 3 under tens is 3 tens. Okay? So that's why I'm showing you all this to explain how it works, so that each one you are transferring is no longer 110. It just depends on where you are moving it. If you are moving one from 100 now to 1000, it's not 110, it's 1000. If you are moving from tens to 100, it's no longer 110, it's now 100. The 10 tens becomes 1000. So that's why I took time to explain all this. Okay? So, but the basic thing you should know is whenever you add and you get an answer that is 2 digits, remember, you cannot write the 2 digits under that column where you added. So write down the one on the right, the digit that is in the unit position, and the other one, you send it or transfer it to the next column. So that's your regrouping method. Okay? In our days, we used to call it carry. You carry it to the other side. So whichever way it works for you, go ahead. If this is confusing, you can just forget about this. This is actually like trying to prove to you why we move what we move. Okay, so the basic thing is retain the one in the unit position and move the other one. Okay, so now the next one we're going to look at is subtraction of whole numbers with regrouping or without regrouping. So now we are looking at subtraction of whole numbers without regrouping. So here we have straight subtraction, 3 take away 2. I don't want to start going into counting. Okay, we are big boys and girls. So 3 take away 2, you have 1. 5 take away 4, you have 1. 8 take away 6, you have 2. And 7 minus 4 or take away 4, you have 3. This is as straightforward as it gets, right? This is not something to waste time on. So without wasting more time, we'll quickly go on to subtraction of whole numbers with regrouping. Okay, so 2 take away 1, we have 1. 4 take away 8, we know that 8 is bigger than 4. So there's no way we can take away 8 from 4. So what do? We come to the nearest neighbor for help. Okay, now remember this 7 here is in the column of hundreds. That means this is 700. So now the least thing 7 can do for us is give us 1, just 1 out of itself. And that one that 7 gives is what? 100. That one is 100. Okay, so when 100, oh sorry about that, I was we take 1 from here and it comes to the tens position. Okay, when it comes to this part, the 4 there becomes 1 and 4, which is 14. Okay, so 14 now is bigger than 8, then we can go ahead and do our normal subtraction. So 1, 4, 14 take away 8. You can just have 8 in your head and count up to 14, or you count back from 14 to 8. Whichever way you choose to do it, you get the same answer. So let's have 8 in our head and count up to 14. 9, 10, 11, 12, 13, 14. So we have 6 there. Now remember, we have taken 1 out of this 7. So what we have left here is 6. So 6 take away 6, we have 0. And lastly, 6 minus 3, you have 3. So our answer here is 3061. 3061. So let's go over this again. You have 4 here. 8 is bigger than 4. So whenever you have a case like this, where the number that you need to take away from the other one is bigger, you need to go to the next digit, the next number to borrow, to get a number that you can use to boost the small number. So whenever you go, you just borrow 1, you bring 1, and once the 1 comes over, it empowers the other digit. Okay, so here, remember this tens, I was trying to talk about this, okay, but I chose to change it to just 14 and 8 so that you won't get confused. But what actually happens here is this number now has become 140, 14 tens rather, because this is 100 you are bringing from here. But remember, this 100, when it comes here, it is like tens, and this 8 here is 8 tens. Okay, so initially we were asked to remove 8 tens from 4 tens, which wasn't possible. So we now came here to 100 to take 1. This 100 we brought here is actually 10 tens. It's actually 10 tens, and 10 tens plus 4 tens is 14 tens. So we are not doing 14 tens, take away 8 tens. So we have 6. This 6 is actually 6 tens, which is 60. Okay, I know you will understand that. So, but I just tried to reduce it to the basic numbers. We just do a subtraction and go away. But actually, you should know that this is not 14. This is actually 140, take away 80. And this 6 you are seeing is actually 60. Okay, so remember, you've taken 1 from this 7. What we have left now is 6. So 6 minus 6, you have 0. 6 minus 3, you have 3. Okay, so let's take one more example. of this before we move on to decimal numbers. So our next example is right here with us. 3,463 minus 1,874. So let's start from the unit end as usual. Here we have 3 minus 4. We know that 4 is bigger than 3, so we can subtract 4 from 3. So what do? We come to 6 and take 1 from these 6 tens. So it becomes, this number becomes 110 and 3 units, which is 13. So now 13, we can take away 4 from 13. So 13 take away 4, you can have 4 in your head and count up to 13 from the next number. So we have 5, 6, 7, 8, 9, 10, 11, 12, 13. So I have 9. 13 minus 4 is 9. Now here we have 5, and the next one here is 5 minus 7. We also find out that 7 is bigger than 5, so we can subtract 7 from 5. So what do? We come here again and take 1 and bring it here. So this number becomes 15, and this remains 3. Okay? So now I'm saying 15. It's not just 15. This number is actually now 15 tens. Okay? Which is like 150. And this is like 70 because it's under tens. Okay, but just let's reduce it to the basic numbers we see here. So let's just take it as 15, take away 7. So as usual, you can keep your 7 in your head, count up to 15, 8, 9, 10, 11, 12, 13, 14, 15. So I have my 8 fingers up. That means 15 take away 7 is 8. Now the next number says 3 minus 8. Again, we're having a problem. What we're taking off is bigger than the number we need to take it from. So as usual, we go for help. So we borrow 1, and this remains 2. So this new number now is 13. Okay, but it's actually 130. It's actually 1300s rather. It's actually 1300s, but we just look at it as plain 13. So what do? 13 take away 8. Count from 8 up to 13. So you start from 9, 10, 11, 12, 13. So I have my 5 fingers up. 13 minus 8 is 5. And lastly, we come here. Remember, because we borrowed 1 from this 3, what we have left is 2. So 2 minus 1, you have your 1. So 3,463 minus 1,874 gives you 1,589. Okay, so I hope this is clear enough. Just know that if the number up is too small, you go to the number before it, you borrow from there and empower it. Just empower it. Now I'm trying to explain why it's like 1300s, 13 tens, 13 this, just for you to understand the logic behind it. But actually you can just look them as plain numbers like 1 and 5, subtract 7, 1 and 3, 13. Okay? You do that, you get your answer. But I want you to understand what is what, not just making you cramp figures. Okay? You really need to understand how this works. Alright, so next we're going to move on to addition and subtraction of decimal numbers. So let's take a simple example of a decimal addition. Okay, please take notes. See the numbers. These are the numbers 145.6 and 254.3. Okay, 145.6, 254.3. Now, if you look at my arrangement to add them, I made sure that the points are aligned. Very important. If your points are not aligned, there's no way your answer can be correct. Why is it important to align the points? The point is where the whole numbers, this is the demarcation, this is where you have the boundary between whole numbers and the fractions in these numbers. So if you go and write a fraction under your whole number, there's no way you can get the right answer. So you must use this point to show where the whole numbers end and where the fractions begin. That's why it's very important. So let's add. This is a straightforward example. You see some other examples. 6 plus 3, that gives 9. And then you put your point. Don't forget to do that. 5 plus 4, 9. 4 plus 5, 9. 1 plus 2, 3. Okay, this one is quite straightforward. It's so easy with this one to align our points, but we're going to see some other examples that may be tricky, and then we're also going to see some examples of decimal numbers addition that involve regrouping, like this one that we just did that doesn't involve regrouping. So there are two things we are trying to look out for now: the alignment of the points and also whether they involve regrouping or not. So we're going to look at another example. Now let's look at the next example we have here. It says 189.7, add 189.7 and 26.4. So if we look at this case closely, we will find out that the numbers, the digits we have here, they are not up to the digits we have here. It's a very interesting one because it's in a case like this that you will be able to, you will really see the importance of having the points aligned. Okay, so let's see the 189, we have written it out first. Now look at that 264. We didn't just write them anyhow. We made sure that the points align. Okay, so you must always ensure that your points are in alignment. And then this also involves what we call regrouping. So let's work on this. 7 plus 4, 7, 8, 9, 10, 11. We can't put 11 here. We've already seen that in earlier examples. So we put down 1 and we bring the other one here. So 1 plus 9 is 10 plus 6 is 16. Bring 1 here. 1 plus 8 is 9 plus 2 is 11. We write down 1. We bring 1 here. So 1 plus 1 is 2. What do we do? Remember, move down your points. Very important. Very important. So 189.7 plus 26.4 gives us 216.1. Okay, so let's take one more example of this. Now let's look at this next example. You see it's a very interesting one. Like here we have 5 digits and here we have just 3 digits. Here we have 2 digits after the decimal. Here we have just 1 digit after the decimal. Now look at the way the numbers are arranged. You will find out that the determining factor here in the arrangement is the point. It's the point that tells you where what number will be. Whatever number is after the point here, it has to align with the number immediately after the point here too. Whatever number is before the point has to align with whatever number is before the point in the other number. So it's the point you used, they must align. It's the point that will tell you. We didn't say, okay, because there is space here, 9 should be here and 6 should be under 2. That would be very wrong. Because here, what the best you can do is add your 0 there. 9 is immediately after the point, so it has to be under 2, which is immediately after the point. This is how we arrange our numbers when we are dealing with decimal numbers. You ensure that the points align. You arrange whatever you have to the right, arrange whatever you have to the left, following the point alignment. That is what determines everything in addition and subtraction of decimal numbers. So now that we have arranged, we can add 4 plus nothing is 4, 2 plus 9 is 11, so we bring 1 here, right? 1 plus 8, 9 plus 6 is 15. We write down 5, we bring down 1. 1 plus 3, 4 plus 1, 5, and 1 plus nothing is 1. So remember your point, you bring it down. Okay, so 138.24 plus 16.9 gives us 155.14. I hope we have really understood this now. This is how we arrange when you're doing decimal. Okay, the next one we're going to look at is subtraction of decimal numbers. So the next one is subtraction of decimal numbers. So here we have 83.12 take away 26.14. Remember, I'm not saying 83.12 or 26.14. No, any number to the right of decimal is not a whole number. So you cannot call it by the names of whole numbers. For instance, calling this 12 is wrong. It's not 12. Its value is not even up to 1. So we can't call it 12. We call it 1, 2, 83.12, 26.14, not 0.14. okay? Simply because whatever is after the decimal point is not up to 1. It's not a whole number, so you cannot call it the names of whole numbers. Okay, so let's do our subtraction. So here we have 2 take away 14. Remember, we have learnt about how we can handle this. So we borrow this one, bring it here. This becomes 12. 12 take away 4 gives us 8. Now we are left with 0 here. And we can't take away anything from 0. What do? We come to the next neighbor here to take 1. Okay? So that one we bring makes this to become 10. All right? But in reality, this is not 10 because it's after the point. Whatever is after the point is a decimal, is a fraction. So, but for the sake of the addition, we just take it as 10. Then that 10 take away 1, you have 9. Remember to bring your point. So what do we have left here? 2. And we know we can take away 6 from 2. So what do? We take 1 from 8. We bring it here. This number becomes 12. 12 take away 6 is 6. And lastly, we have 7 left here because we took 1 from 8. 7 take away 2 is what? Is 5. So that is our answer. When you take away 26.14 from 83.12, you get 56.98 as your answer. So the last example we are going to consider is the one we have right here. Subtract 3.567 from 24.32. Okay, so remember when we say subtract this from, the one you are subtracting is the smaller number, so it should be at the bottom, and the one that carries from is the bigger number and it stays at the top. Now again, look at our arrangement. Look at the way we arrange the two numbers. You see that no other thing matters. They don't have to all stay straight. Do you get it? They don't all have to stay. What matters, what must be straight are the points, the arrangement of the points. They must be straight, they must be together. If the points are not on a straight line, then your work can never be correct. Okay? Now, but have a look here. We have just 2 digits at the top part here. Here we have 3 digits. So what do? Okay? If there's empty space in numeracy, in math, feel free to put a 0 there. Because 0 means nothing, right? So in that space, we are very okay to write a 0. Okay? Now, can we take away 7 from 0? No, it won't work. So what do? We borrow 1 from this 2 and we bring it here. So this becomes 10. 10 take away 7, we have 3. Now remember we took 1 from here, so here is 1 remaining. We can't take away 6 from 1. So what do? Again? We take 1 from here and bring it here. So this becomes 1, 1. I call it 11, but it's not 11 in reality. So 11 take away 6, we have 5. This is for the sake of just subtracting, okay? So then we have 2 left here. Now what do? We take 1 from 4 because 5 can be subtracted from 2. So you take 1 from 4 and this becomes 12. So 12 take away 5. You have 5, count up to 12, 6, 7, 8, 9, 10, 11, 12. You have 7 there. Okay? Next, remember to bring down your point. So we took 1 from this 4, so that means this is remaining 3. 3 minus 3, we have 0 here. And 2 minus nothing, we have 2 there. Okay? So basically, the way we do addition in whole numbers is also the way we do it in decimal numbers. But the basic difference is the alignment of the points. You have to make sure that in decimal numbers, your points are properly aligned, or else your answer can never be correct. Arrangement does not depend on start from the unit when you are dealing with decimal numbers. Unlike whole numbers, you always ensure you start arranging from unit. But in decimal numbers, what matters is make sure your points are aligned. Make sure the last digit before the point aligns with the last digit before the point in the second number. Make sure the first digit after the point in the first number aligns with the first digit after the point in the second number. Those are the basic things that you need to look at whilst you are arranging your numbers for either addition or subtraction of decimal numbers. Okay, so the decimal matters a lot. But in the case of you have a big number and you need to subtract, you have a small number, you need to subtract a bigger number from it, going to the other number to borrow to get something that will empower that digit is common to both of them. The way you do it for whole numbers is exactly the way you do it for decimal numbers. It's basically the same thing. So once you understand how you do your addition and subtraction with and without regrouping for whole numbers, you will definitely be able to apply it to decimal numbers. They are the same thing. The only thing you take note of is your point, your decimal point. Okay, so here is where we're going to call it a day for today. We hope to see you again next week. Please help us share the video, like the video, okay, and stay blessed and stay safe.